Sudhir and I are going to talk to you about proven techniques to build a trusted software supply chain for your AI models and AI-enabled applications. That's Sudhir, Director of Product Management, specifically Trusted Software Supply Chain and Data Services. My name is Mike Foster. I do technical marketing for OpenShift Security. And what's on the agenda? We're going to talk about some of the challenges and expectations for AI app development and deployment, how Red Hat specifically enhances security throughout the AI model and app lifecycle, and then we're going to talk about how Red Hat's trusted software supply chain helps to manage risk, integrity, and build safety across the software development lifecycle and model development lifecycle. AI is a hot topic. I don't know, you can't get away from it. It's everywhere, right, this week. But there's also some concerns that we want to talk about that we're seeing with our customers and some of the analysts are seeing as well. This number is pulled from a few analyst briefs. We've seen 12 to 30% of POCs to production. It ranges. There's a bunch of challenges that our customers are facing. Data model ambiguity challenge. There's widespread adoption, but they're facing issues with test data versus scaling in production, getting the same accuracy in production. We're also seeing infrastructure issues, scalability, MLOps, integration. How do you pull something from a POC that's in a single VM and deploy it into Kubernetes or onto AWS and link it into all of your workloads? We're seeing challenges with infrastructure, challenges with the lack of assurance, AI security and safety, so governance, risk, and compliance, AI safety, lack of explainability. And then we're seeing some of the people issues. So down underneath 4 and 5, undefined success criteria. So do the business challenges and the outcomes match up with what you're actually deploying in AI, with AI? And then people's and processes, challenges, skills, fear of job replacement. So we want to talk specifically about infrastructure and platform and governance, risk, and compliance today. Now, Red Hat's security approach. We've been building platforms for 30 years. Started with Red Hat Enterprise Linux, and we always start with that strong foundation, built in at the operating system layer. Then we tack on infrastructure and automation with Ansible, a hybrid app platform with OpenShift, all to allow you to deploy your AI, ML apps, your virtualization workloads, all on top, again, with that security and safety built in underneath. A good example of this, I've mentioned already, RHEL's inherent security. We've been doing this for 30 years. SE Linux, cryptography libraries, application sandboxing, confidential computing, all extending seamlessly into the app platform above it. And again, that's your core layer when you're deploying AI models. Now, if you're using AWS, you might just be deploying and having it self-managed. If you're on-prem, these are all considerations that you have to think about. And then when you're deploying on-prem, you also have to think about how you're going to move those workloads into the cloud, and that's what Red Hat enables you to do. Lastly, this is the layer cake slide. Again, we have that underlying layer of Linux. We have Kubernetes, the foundational application platform capabilities on top to allow you to deploy AI and all your middleware and allow you to not have to worry about those underlying details, especially when you're deploying on-prem or in things like Rosa, Red Hat, OpenShift on AWS. Now I'm going to pass it over to Sudhir, who's going to talk AI safety and security.
Thanks, Michael. So let's get down to more kind of AI application and AI models. The large language models are here, especially with Gen AI. It's running all over the place. It's writing the code. It's doing diagnosis for even the diseases right now and even interacting with customers, right? The question comes that is it secure and safe? Traditionally, we are worried about the security, right? Supply chain security, external actors coming in, trying to hack the things or trying to inject some of the malicious code, right? With the Gen AI, one of the other aspect of security is safety, because you have an embedded Gen AI model that itself can cause some harm, right? Or it may have inherent bias. It can create some of the contents which your company may not want to do that, right? The other biggest challenge is how do you explain that this is what the Gen AI is doing, right? The customer wants to know that, you came up with this decision, what exactly really you did that this is the outcome, right? So we want to address both the security and the safety. But it's not that we have to invent these things new, right? And traditionally, we have handled this thing for software development lifecycle. We do see the software development lifecycle and model development lifecycle merging, right? So you do actually take a Gen AI model, create an application, You fine tune the model because it's not behaving the way you want it, right? And then you again feed that to the application, right? So we do see the merging from both of these things together. And we have to handle both the software integrity as well as the risk profile for both of them, right? For Red Hat, we have trusted artifact signer. The main goal is to make sure at each step we can ensure the software integrity, right? Sign and verify, you know the provenance, and you attest it, right? The key thing is that if you do fine-tune your model, you want to know exactly how you trained it, on which data you trained it, so you got that outcome. So the next time when you fine-tune it, you know that this is the modification you have done, right? Generally, we don't get this thing with the foundation model, but if you are taking it and adding weights, right, you do want to get a lineage of both the data as well as the fine-tuning process you did, so that you can actually go and refine it the next time, right? This is for doing the software integrity. The next is risk profile, right? You do want to know the risk profile. You can't really go and get rid of all the risk profile, right? Even simple thing like CVs, you can't get rid of them from all the software, right? Same thing with the safety concerns. It will always be there, but the key is that you should be aware of what the risk profile at each step, and actually have something to mitigate it. For example, developers should know that if they are using these libraries, this is the risk profile they see with that particular library, and probably they can go to the next version or what they can do to mitigate it, right? That's the main focus of Trusted Profile Analyzer. Same thing, we want to do it that even if you have developed the application, if the risk profile changes, you do want to get alerted. It's not a one-time thing that you do and develop an application using a model and then you go there, right? Because new attacks can occur or new CVs can be found, and then you have to go and react it. Let's look at some of the practical use cases, what we have done in terms of how we have implemented that if you're developing an application or if you're developing even the traditional chatbot, right? We have an open source project called Trusty AI, and the key focus for them is explainability, that exactly how did you come up with the decision. Then you have LLM evaluation framework and the guardrails, right? The explainability is very simple, that you do want to explain to a larger extent. It's not yet figured it out in the whole thing that how exactly the LLMs come to decision, right? But your application should be able to say that I came up with this decision because I follow these logics, right? That gives the confidence to the auditors as well as your legal team that it's okay to go to production, right? Same thing with LLM evaluation. It's not about evaluation for your performance, right? It's also evaluation of the safety metrics. So it's the fairness, bias, toxicity and all. You need to be aware that this is the safety parameter of your LLM and what you do to mitigate it, right? Last but not the least, the guardrails. There are many types of guardrails, right? The main purpose is that depending on what risk profile you see, suppose it's a bias, right? You can add those guardrails which can filter both the input and output content so that you can actually protect your application, not really crossing some of the content, right? What it basically takes it from customers and not react in a way you don't want it to react, right? One of the main concern has been that the LLMs, GenAI specifically, right? It's very ambiguous, right? Depending on how many prompts and what session, right? It can answer in different ways. So you do want to protect them, and guardrails actually does a very good job of at least in filtering both the input and output content to protect from privacy and other stuff. So how do we do that, right? The first thing is that any model you use, regardless of whether you created them or you're using a foundation model, do some kind of LLM eval, right? There's many tools. In this one example, we use the LLM eval, right? It gives you a kind of a view of from 0 to 1 that what's the bias metrics, what's the toxicity. Green is better, red is not that good, right? But you will get this with every model, right? There's no model where you will get all the greens, right? So you want the developers to be aware if you're choosing these models, this is what you are going to see, this is how it performs, and it varies with different versions, right? It even varies if you go and change the weight or you add different prompts to the model, right? So the goal is that you run this thing and get a blueprint that this is what your model is going to behave or your application will behave, and safeguard it against the guardrail, right? That's the whole idea, that you get the visibility on that one, right? We have found this very useful. You saw the AWS also, a lot of people are using the guardrails to protect their application against any of these biases, right? You don't want to do this at the very end. You do want to do this starting from the developer when you are using the model, right? For example, in Red Hat, right, we have the dependency analytics. If you're using a model, you get the blue cursor line, right, and you see all these metrics that, hey, we see the truthfulness like this one, right, or in toxicity 0.415. Depending on the tolerance level of your particular application, whether it's external or internal, you may decide that how do you protect your application against these kind of metrics, right? Once the developer adds the visibility, right, you do want to alert them that looking at this particular aspect of your bias, right, you may want to add some of the guardrails, right? You don't want to add all the guardrails, right, because it does slow down the application because it does filter both the input and output, right? The idea is that based on the metrics and profile you see, either you go and reiterate and reevaluate the model or fine-tune the model or distill the model, or you come back and add some of these guardrails, right? So if the developer is aware, they may choose a different model and they may actually go ahead and add some of these guardrails, right? That's the whole idea, that help them at least add the safety and security from the day one. It's very difficult. There are many types of guardrails, right? So our idea is that at least, and this particular, when things are emerging, help them actually code them developers, right? So for example, if we see that they are using Llama Stack, we will go ahead and add them, hey, this is the code you should be adding for the input and output, and this is the filter you should be adding given your profile of the model you are using, right? So this is one example of Llama Stack. There are many types of guardrail. It doesn't, at this point, they're all evolving. The key is that what filter you are using, right? If you're trying to protect against bias, then it's one filter. Trying to protect against toxicity, that's a different filter. So you equip the developer, and then you actually go ahead and once the application is running, right, you have to monitor it continuously, right? Not only for the CVEs, but also even the bias metrics if it changes, right? The whole idea is that the model itself can drift, right? Not only in predictability of what kind of questions it answers, but also as it's running, right, different kinds of prompts and the interaction can cause it to really give a different response. So you need to have a runtime monitoring for that. This is where Red Hat Advanced Cluster Security helps. It will continuously monitor it, any risk profile change, right? Or if you are seeing a lot of guardrail attributes showing that someone is trying to break it, you do want to go ahead and take care of that in fine-tuning in the next version of the model, right? We call it agility, so that you don't hold back just because you get the perfect application. You ship it with the guardrails and monitor it. If you do see a risk profile change, you come back and actually go and change it, right? Transparency, right? That's the other aspect, right? Once you have a foundation model, generally they are not publishing the SBOM, but if you are taking an application and using some sort of LLM, you should create an SBOM, including the AI models you are using, all the weights you are using and everything, so that even your team knows that exactly what all training or fine-tuning you have done, so that they can, next time they go and actually fine-tune it, they know how to go and do that, right? And this has been the missing piece. We are working with the industry to even see that all the foundation model can actually publish their AI SBOM, but at least what we suggest and what we have implemented is that for applications using AI, right, at least they should have an AI SBOM so that we can actually know what exactly contains on the particular application, right? Then protection from attacks, right? There will be attacks on your application, just like we used to have the security threats from in the earlier days. Because you have LLM, there is a prompt injections. There are attacks where they will try to steal the data which you are trained on, even the model weights and everything, right? The guardrails, what we have found is that when very useful. So they actually, either you embed that in the code or you actually have that data surrounding so that you can actually know that these kind of attacks are ongoing and you can protect it against that. It gets very complicated, but the key is that, just like we used to have end-to-end and a secure supply chain before, right? You have to start from the developer, shift left as much as policy, implement the security, not in a manual way, but in terms of automation. So this is where I showed you that, trusted application pipeline, right? It sets all the security guardrails end-to-end, right? It automates using the backstage in Developer Hub. so that the developers actually knows that this is the security profile, and they can have the policies that this is allowed or not allowed, if they are using the guardrails or not using the guardrails. You give them the risk profile, you use the model, scan it, and then you deploy them and have the continuous monitoring using any tools you like, right? In Red Hat, we have the advanced cluster security tool, so that you are aware the risk profile changes, then you can come back and actually go and reiterate the application.
Yeah, you nailed it, Sudhir.
That's the short I had them.
I was going to say, I think the summary is, it's similar to the container lifecycle, right? You want to use trusty AI early in that process, verify what model you're using, make sure that you're onboarding it, seeing what the package dependencies and things like that are, make sure it's cryptographically signed, make sure you have a runtime enforcement mechanism, right? You're doing all of those pieces, and that's really going to help with that percentage and help you get past those security and compliance checks, legal checks later on. So you can take your POCs and get it to production as fast as possible. Again, similar story as containers and virtual machines as it is with AI. Make sure you're doing your research first and building in those security guardrails. You're able to iterate way faster once you have those guardrails, and you're able to go to your security and operations team and show them that you're taking all the key steps to secure AI. Hopefully that nailed the summary. Yep. That's what I got from the talk. Thanks, Sudhir. We got a few links for you guys if you want to learn more about Red Hat Trusted Software Supply Chain and Red Hat AI. We're also at the booth right there. We're giving out black Red Hats, but if you just find me, I'll be able to answer any of your questions or direct you to somebody who can. Thanks again, everyone, for joining, and I hope you really enjoy Philadelphia this week and get home safe on Wednesday. Thank you.